Hello and welcome to our Smart Panel, an introduction to IPMX. Today's webinar is brought to you by sound and video contractor Matrox and Plexus AV and produced by Future B2B. My name is Scott Becker. I'm from Future B2B and I'm excited to do a little moderation here for this timely discussion. Now, before we get to today's great content, we do have a few housekeeping items that are going to help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. The Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh will fix most audio, video, or slide advancement issues, but if that doesn't work, just let us know there in the Q&A and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to a white paper from Matrox about the IPMX network and a link from Plexus AV about the rapid adoption of IPMX. So I encourage you to access those resources now and share them with your friends and colleagues. Now, third, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. The official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the link with the details there. Okay, well, with that housekeeping out of the way, let's get to today's panel discussion. So it's my pleasure to introduce you to our host today, Mark Pescatore, who is the content director for Systems Contractor News. Mark, welcome.
Thank you very much. And everybody, thank you for joining us. Again, I'm Mark Pescatore. I'm the content director for Systems Contractor News. Now, let's be honest. Our industry is used to format wars. I'm going to take you back a little bit. Remember VHS versus Betamax? Or a little more recent, but not that far away, was 1080i versus 720p. Well, now the format war is all about AV over IP protocols. This webinar is all about getting you up to speed on one particular solution that's been developed for the pro AV industry and beyond. So welcome to this introduction to IPMX. Joining us to answer your questions and get the conversation started is Sam Racine. He's the Vice President of Strategic Partnerships at Matrox. He's also the chair of the Pro AV Working Group at the Alliance for IP Media Solutions Alliance, also known as AIMS. There's also Aaron Doughton. He is the Director of Technology and Marketing. Aaron Doughton. He's the Director of Technology and Marketing for Plexus AV. Gentlemen, thank you for joining us today.
Yeah, thanks for having us.
Thank you.
Oh, sure. Now, let's ask the easiest question first. What is IPMX and what makes it different in the marketplace?
Want to kick it off?
Perhaps the easiest way to start that is to mention that it's based on SMPTE 2110 standards. So what is IPMX? It's a combination of standards and open specifications, a few of which come from AMWA network media open specifications, and most of which are defined in the VSF TR10 open specifications, and a few media profiles defined by AIMS. So that whole group of things together is what IPMX is. A much easier way to think of it is if you think of SMPTE 2110 as the IP equivalent or analog to SDI, IPMX is expanding that to be the IP equivalent to SDI and HDMI. So IPMX deals with all of the consequences of the type of content that normally gets handled by HDMI cables.
Yeah, definitely. I think one of the big things that people need to know, and Sam kind of hinted at this, is that SMPTE 2110 is that foundational base of what IPMX is, and that's like an alphabet soup of letters and numbers. And what it really is, it's just the technology that allows us to move, audio and video around in an IP network. This has been in the broadcast industry since 2017, has been widely deployed, has pretty much replaced everything with SDI and has now moved everything to IP. So it's not necessarily in its infancy. It's based on something that's been, kind of had its trials and tribulations, gone through the fire, and came out the other side as kind of the dominant AV over IP, technology and broadcast side. And I think, as an Ames member, along with Matrox, I think we looked at it as, there's this convergence of technologies, and the pro AV space and the broadcast space are kind of slowly creeping in on each other's space. And we looked at it as well. This thing's really powerful. Like, everybody could benefit from it. So let's modify it, make it smart. Let's make it usable for the pro AV space. So I feel like there's a little bit more of the human interaction and kind of plug and play experience that we're trying to introduce to what is a very, very powerful AV over IP technology stack, essentially. So a lot different approach compared to some of the other stuff that's out there.
Well, now we're definitely going to get a little bit more into the technology, but let's do a little history first. Gentlemen, how did we get here?
Yeah, so Sencor has been, since Sencor is the parent company, I guess, for Plexus AV, and Plexus AV is our, our venture into the pro AV space. But yeah, we got here by getting sick and tired of the format wars, I guess, as you hinted at. So, going from your standard definition to HD, and then from HD to your full HD, and now full HD to 4K, and about HDR standards and all of this other kind of stuff. Every single time that technology is changed, or a need for higher quality video or audio, it just requires a complete revamp of everything, right? Your cabling doesn't work, your signal infrastructure isn't something that can be upgraded or retrofitted, and so it's just this constant, it's this vicious cycle of reinventing the wheel. And obviously that's where AV over IP comes in as kind of a concept. But I think this takes it a step further, where from its core planning and how it's been developed and standardized, is that if we want to do 8K in the future, we can. If we want to do high frame rate, like 240 frames per second, sure. You want to do a new HDR standard, whether it's dynamic or, I don't know, something that's, somebody smarter than me is probably going to come up with something that's amazing for for contrast and colorimetry and all of that kind of stuff. But this is more of like that, just the foundational moving and controlling and monitoring of that AV over IP system. So it takes it a step further. Instead of just being this, like a chipset or something, a chipset or an SDK. This is like actually a series of standards that talks about carrying all of these things, and these can be changed and amended and be backwards compatible and interoperable and things like that. So yeah, that's how we got here, is just getting sick and tired of reinventing the wheel. This is kind of that foundational piece that allows us to just keep building and building and building towards whatever we want to in the future. So
Now, this didn't just come out of nowhere, though. I mean, and you want to build for the future, but that means you've been building. You've been in the process of building stuff. And part of that is the interops and dirty hands and other sorts of testing. Some of us have heard the term dirty hands and some of us haven't. Sam, what testing has gone through, what testing has IPMX gone through to make it a viable alternative for Pro AV?
Well, like Aaron mentioned, the TR03, which eventually became 2110, has been out since about 2017. There's hundreds of products that have been tested through forums like the JTNM and various type of interoperability tests put on by the EBU and other organizations. With IPMX level of specification specifically, there's been a series of interops that have been done starting back in 2022. The more widespread one started in 2023. There was a major interop towards the end of 2023, and then another one right before the ratification and publication of TR10 in January of this year. And then at ISE in Barcelona, the VSF TR10 specifications were converted from draft, which they had been in for about 2 years, into final form. And there was another interop being scheduled either for late this year or early next year. So in all, there's been dozens of interops with the IPMX feature set specifically. There's been three major ones, and they usually get put on by the same folks that put on the SMPTE 2110 type of interop testing.
You know, it's funny when I do a product review for my magazine, I joke around and say, it's basically it's my job to try and break it without dropping it on the floor. And it sounds to me like with these interops, these dirty hams, it's all about trying to find things you need to fix. Is that generally how it works?
No, I think that I'd like to hear Aaron's perspective on this too. But I think that one of the most important things that the interops are going to focus on are the fact that IPMX is intended to be scalable and future proof. So it supports different media types. So there are profiles of IPMX for uncompressed media. There are profiles of IPMX that use codecs. And so these interops are there to test each of these combinations. And there's also gateways that allow you to convert between one and another. So these interops are golden opportunities to make sure that everything works.
Mm-hmm. Yeah, and I think from my perspective, I would echo exactly what Sam just said, but I would say that, at least from my perspective and my experience at Plexus and also at Cencor, is that it is actually a great way to check for that interoperability, make sure that when you finally get into a distributor's or an integrator or an installer's hands, you're not, not working, right? I think it's just a amount of proving out technology and finding bugs before it actually gets into the end user's hands or something that's going to be planning or system architecting, right? Like that can be a huge pain point. And then you're like, you're already up against some deadlines or something like that to deliver a system. And now you're like reporting some major issue to a company. It's just the support aspect of it. And so we're trying to get as far ahead of that as we can. And, to make little tweaks, you're always going to have to make changes and things like that. That's fine as a manufacturer. But to do that as much ahead of time and even get ideas and actually talk about with, sometimes you're at interops with what I would consider frenemies. You know what I mean? It's like you're competing with them in some cases, but you also have to be working with them as well. So it's kind of an interesting, community of developers and yeah, I guess the frenemy thing. It's like you got to kind of play nice in order for everyone to be successful, and I think that's why it's such a good technology and community to be a part of. So.
And one little extra thing on this topic, because we're talking about interops, IPMX does not need to be put into one particular type of processing. It can be put into software. It could be put into an FPGA for hardware-based solutions. It could be put into an ASIC. It could be accelerated by a CPU with libraries. So because there are so many processing implementations of IPMX, this is also a venue to test between different types of underlying processing technology for the standards.
Yep. And the control and management of all the devices and the streams as well. That's a big part of the interoperability of IPMX is everybody can talk to everybody else and steer streams around and stuff like that. So to make sure that you can do that between different vendors and things like that is very important. So, yeah.
Actually, I want to touch on something that you just said, Aaron. You were talking about community. It sounds like you're not just building a standard here, but you're actually building an IPMX community. Would that be fair?
Yeah, I think that's very fair. And I feel like that community not only is a part of the development of it, but the businesses that we work for are building either software products or hardware-based products or any of that kind of stuff, but also we're the ones providing feedback into the standards bodies and the organizations that develop the technology too. So that helps us provide more of that actual real world application amendments and stuff like that happen to the technologies, right? So it might look great on paper, but then you go to try to accomplish some special project and maybe that feedback into the standards body is what evolves it and keeps it moving forward. So yeah, I think it's important for all of us to have that.
Yeah, Sam, how important is having a community for IPMX?
It's paramount, and IPMX is not just a community between developers of IPMX products and technologies, but also between communities. So IPMX is striving to have compatibility with SMPTE 2110 and AES67. There's been projects that have been performed where Dante devices were using the Dante Control Manager put into AES-67 mode and had interoperability with IPMX equipment. So there's education, there's learning that goes even between communities. Is very important. Obviously, there's a lot of knowledge to disseminate in the channel, and consultants and users and manufacturers. So these communities and gatherings and workshops and forums are very, very important.
Well, now I'm gonna ask the question that everyone's been wondering about, and I ask you this every time I see you at a trade show, and I know you see me coming, Sam, and that is, have the standards and the specifications been released?
Yes, the specifications for IPMX are released. They're on the VSF website, so the Video Services Forum. If you go to the main homepage of the VSF website, it's on the homepage, the link to the IPMX technical specifications. The IPMX TRs on the VSF website refer to the AMWA specifications that you need in IPMX products, so that's all included there. The thing that's under construction now is a labeling system. So just to make it easier for manufacturers to identify what their products support. So IPMX supports so many things. There needs to be a labeling system to assist users to understand what they're buying. So as I mentioned earlier, some IPMX products support uncompressed media, some support compressed media. There's a variety of codecs that are supported. So a labeling system is being developed so that users can see, oh, okay, I can buy these two uncompressed products from different brands and they will work together. Or I can buy these two products that use the same codec and they will work together. Or I can buy a product that supports multiple formats and it will work with any of the other vendors' products that support the same format. So there's a labeling system that's still under construction, but the specifications themselves, the first wave of them at least, are released.
I'm going to have to come up with a new question to ask you next time I see you at a trade show. But now that we have that, what is the roadmap for IPMX moving forward?
Oh, there's several things. I'm sure that Aaron is going to think of some to add as well, but right now there's a new TR to add USB support. So there's plenty of things that are being added. So USB support, PTZ controls, additional things that are required for the Pro AV world.
Yeah, I think FEC, there's some new content protection stuff going on there. I know the group is working on some, in addition to, I guess, just the standards and things like that, but also some best practices and just kind of help on the education side, right? Get people understanding like how they, architect systems and stuff like that, kind of like a how-to guide for making your own IPMX system. So that together with this certification and labeling program will help people kind of go like, okay, I want to build a gigabit network for IPMX and my application is this, and I need to be able to support these things. You'll be able to correlate and, understand how all of that stuff works and, understand how deep down the rabbit hole you need to go in order to, if it's a simple system and you pull something off that's simple, you'll be able to easily understand what all that looks like. So, yeah.
Okay, so the labeling system, I guess, Sam, that'll be the next thing I start asking you when I see you at ISC. When will the labeling system be ready?
Yeah, whole wave of things coming. There's a labeling system that's probably going to be talked about at ISC in January or February. There's an IPMX training being developed. So Ames has commissioned a course to be developed, very similar to some of the other protocols that have courses where you can do a block of whatever it's going to end up being, 15 or 18 hours, and qualify for Pro AV engineering credits at the organizations that offer credits like that. So there's courses coming, and updates. As Aaron pointed out, to the specifications themselves that add new features and capabilities. So it's going to be a very, very busy 2025. Lots of new things being added to help with communications, education, features, capabilities, interoperability, etc.
Well, now, something you mentioned early on in this webinar was SD2110, which makes me think about broadcasters, of course. What is the relationship between IPMX and SMPTE?
Well,
Yeah, so
SMPTE, yeah, go ahead, Aaron.
yeah, so SMPTE is just the organization that they're not just the keepers of just like video and audio standards either. They do a lot of like just in general like industry standards and things like that across many industries, but they are the kind of the keeper and the process of what makes that kind of open standard, right? So they are the standards organization that then aims then works to they're like one of the key pieces of it, right? So there's SMPTE, there's the VSF, there's EBU, there's AES. I mean, these are all again alphabet soup stuff, but organizations within the audio and video industries that are coming together, and SMPTE is just one of those organizations that helps just with the process and make sure everything's documented accordingly, and we're following the rules of what a standard really is. And so that's kind of the I don't want to say gatekeeper because that sounds mean, but definitely the just the keeps everybody honest within all of the organizations when it comes to actually developing the standards, and kind of puts the big rubber stamp on it when it's done. And
First
that's
line of
who
defense.
they are.
The first line of defense for.
Yeah, that's a good way to say
How
it.
about that? So if that's your relationship with SMPTE, tell us about the relationship between IPMX and AIMS.
I'll let you take this one, Sam.
AIMS is a communications organization. It's a market feedback loop organization. It's a not-for-profit organization made up of manufacturers, academics, users, integrators, and various different types of organizations. And the only purpose of AIMS is to communicate about what's going on in organizations like the VSF and AMWA and SMPTE and the EBU and AES, as well as to gather feedback about what the market is looking for next, what they're prioritizing. All of the events that you see AIMS pavilions at, the people there collect all of the market intelligence from those events and bring it back and report to all of the sister organizations that have engineering meetings to discuss ways forward to deal with those issues.
Got it. All right. I just want to remind everybody who's watching, you can ask your questions. Go ahead and put them in the question area, and we will get to them near the end of the webcast. We will get to them, though. They're starting to queue up. I just want to make sure everybody has a chance to ask. All right. So we understand the relationships now between IPMX, AIMS, SMPTE. Who is building IPMX into their products? I know two companies. What a surprise. You happen to be here. But who's actually using IPMX now, building them into their products?
Well, there's a few that have made public announcements in some form. So obviously the two companies on this call have, but there's a lot of traction in the display market.
I knew that. Sam. That I knew.
About the display market?
You two I knew. I knew you two. I knew you two were in there.
Yeah, so no. In terms of in terms of the display market, the LED walls, there's dozens and dozens of brands of LED tiles, but most of them are powered by the same common LED tile processors. Most of those tile processor companies, all of the major ones, have announced support for SMPTE 2110 and IPMX. So almost all of them are already supporting 2110, and the majority of them have said that they're adding IPMX as we speak. Some of them are already working with shipping products. Still, on the premium display side, projectors and commercial displays that use smart display module technology they have options now. There are SDM modules. There's at least two companies that have introduced smart display modules that work with projectors and commercial displays that use SDM. And there's over 1,000 different displays that use SDM technology. There's obviously software. So at Infocom, you saw user-facing software to do software IPMX on computers being shown by Intopix, their titanium product. There are transcoders, so IP to IP gateways that allow you to convert different IPMX formats from one to another. So, for example, uncompressed to compressed media with IPMX or compressed to uncompressed. So those have practical applications in both senses. So sometimes people want to take a camera that is transmitting JPEG XS, but load it into a processing platform that deals with uncompressed signals. So those converters help with that. Or sometimes people want to go from a 2110 network that is usually uncompressed and do distribution of the AV signals on a much bigger network, and but for that they want a much simpler network with just 1 gig. So converting the 2110 signals to a 1 gig IPMX, is a useful combo, and also gateways to convert between protocols and media. So there are already products that have been announced that can convert from NDI into different media profiles of NDI to IPMX or vice versa. So you can go from H.264 with SRT to IPMX, or NDI with NDI full or SpeedHQ to IPMX, or vice versa. So there's products like that. There are testing tools that are in the market for IPMX. There are IP licensing providers. There's at least 2 companies, possibly a third, that will reveal themselves at ISC that offer IP licensing for implementers of IPMX into FPGAs or software. So there are companies that have talked about virtual capture cards for IPMX. So they already support 2110. So DeltaCast, for example, has a virtual capture card that supports 2110, and they have said that they're adding IPMX support, so that what a virtual capture card does is it allows you to find an IPMX source, bring it into a PC, and the virtual capture card behaves like an HDMI capture card or an SDI capture card, and has the mini drivers that provide hookups to all of your favorite applications. So you don't have to do a lot of work to make the source available in your favorite software, whether that's a corporate communications tool like Zoom and Teams, or a video production tool like vMix or OBS or whatever. So there's stuff like that that has been announced. Obviously, production equipment. So Barco, the Encore 3, they already support SMPTE 2110, but have announced that they're planning on supporting IPMX with the brand new Encore 3 presentation switcher. And a second presentation switcher that has announced support is Pixel Hue with the Q8 processor. So yeah, I could keep going on, but there's actually quite a nice mixture.
Yeah, it sounds like you've got a whole bunch of different products from a whole bunch of different parts of our industry. So you're going to have a comprehensive system using IPMX, which is really kind of the goal, isn't it?
Yeah, and please don't forget, there are already hundreds and hundreds of shipping products that are SMPTE 2110, and many of those can work in concert with IPMX products. And there are thousands of AES67 products, and those are also very often able to work with IPMX products as well. Maybe there's a few extra steps to make those other products work, like they're not all automatically manageable under an NMOS controller environment, but they have compatibility at a media level, so it is possible to use them as well. So there's actually already thousands of products that could be put onto systems with an IPMX core.
Now, Aaron, speaking to that, how important is IPMX to the fabric of Plexus AV?
Well, it's very, very important. Kind of some of the points that we've made in terms of, it being kind of the foundational technology for an industry. Obviously, it's a foundational technology for Plexus AV as well. But again, it's building towards that community that is actually driving the industry forward and all of that kind of stuff. So it's very important from not just like a technology standpoint, but from like, the vendors, the manufacturers, the end users, like all of that, that AIMS group that surrounds IPMX, right? That's what I think is important, at least for me, as like a technology and marketing person, is to like have an industry kind of like move forward as this like one carrying a flag that everybody can be proud of, right? And kind of march forward and just have something that's going to be interoperable and open up a bunch of use cases that I think a lot of people would either have to build separate systems for or whatever. It's just going to open up a lot of business and opportunities for everyone that's involved. So we're just excited to be a part of it, I guess.
Well, now, Sam, you and I have been talking about IPMX for a couple of years now. Why is IPMX so important to Matrox?
Well, think of the alternative. The alternative is Matrox, who provides essentially audio and video equipment to assist with routing or to do KVM applications or to help in control rooms with collaboration or to do any number of audio visual media tasks, would have to support this entire suite of incompatible things in order to participate in the market. We would have to have support for 2110 and NDI and SDVOE and Dante and. So the standards are there to help. Maybe some of those other protocols that do exactly the same thing, not all of them need to be supported, and enough equipment exists to build useful systems out of the standards. And for everything else, where those other protocols are still useful, IPMX doesn't belong to anyone. So just think of what my colleague is on right now. He can maybe talk about one of his products that does NDI to IPMX conversion. I mean, think of this for a second. Imagine going from a AES67 source, like a Dante USB to a network dongle, use the Dante control manager, put it into AES67 mode. That Dante product is on an IPMX system, and Aaron's product can convert it back into an SDM module that powers an NDI display. It's you can actually go between different protocols through IPMX as a standard as well. So, IPMX should help federate a lot of equipment under one standard, but for everything else, it's also the best thing to bridge all of the other standards. And most importantly, because it supports many different media formats and doesn't have any caps on what you can do in a chip or what you can do in a certain level of processing power on a CPU or an FPGA, it's the most useful thing to put in the middle. So if you have a big system, you can have a 2110 island on that system. You can have a Dante island on that system. You can have an NDI island on that system. And you could use IPMX to be the glue between those islands.
Yeah, think of it as so kind of throwing back to what we were talking about before with the format wars and having to decide on one versus another or completely rebuild a system that needs to support 4K or something like that. To Sam's point, you could have the island. You don't have to bulldoze or blow up that island and start from scratch, right? That you connect it to your IPMX system and you do the gateway function, the conversion function, and you're able to then route that around to other systems or other islands within your AV over IP network. And I think that's an important thing. It's not to like completely disrupt and tear down. It's to facilitate and enable, right? So I think it's a very different concept of I think a lot of the AV over IP systems that are out there, right? They kind of strongly tote their own, they are the island. They want to be the island and the only island, where we're like, well, that's not exactly how the world works. And IP is IP, right? It's just infrastructure. So how can we make something that is friendly with audio and video and routes those things around in a way that makes sense for everyone? So yeah, it's just a different approach.
And the information to build IPMX products is license free. It's available openly on the internet, and anyone can use it. I'll give you an example of some real life things that happened. There were some companies saying that they wanted to use their HD-based wall plates and as easily as possible get those signals on an IPMX system so that they could bridge all of their rooms together on a campus. Well, there's one company that said, HD-based is associated with like low cost. We don't necessarily want to put a heavy metal encoder on every wall plate to make each one of those things available, on an IPMX system. What if we could put an HD-based in the way where we could grab a couple of wall plates and, you only use the ones that you need at any one time on an IPMX encoder. And so the company built a, HD-based switcher, added support for NMOS in their switcher. And from an NMOS controller, you could actually control which of the HD-based devices you want to see. And different IPMX senders and receivers. So there's actually two levels of switching occurring on the NMOS controller, a baseband switching and an IP switching. And this is just because people picked up the open documentation and started, problem solving and, hard weekends work. And lo and behold, people were building their own solutions.
I actually want to go back to your metaphor a little bit, saying all these different formats are an island. I almost see it in my head, and tell me if I'm wrong. Please tell me if I'm wrong. Is you have a circle of islands, and in the center of that circle is IPMX. Fair?
It's actually the most appropriate thing to put in the middle because of its elasticity. Like IPMX, just on time alone, just on synchronization. If you want to use IPMX with the most demanding synchronization on a system of the biggest scale, if you're using a very high fidelity Grandmaster, using a boundary clock switch and building that type of system, an IPMX device can use that time and synchronize to that type of Grandmaster. If you want to build something like with a level of sync like a Dante level, where you're using regular network switches, nothing special. There's PTP on the system, sure, but it's a much, more manageable level of PTP. IPMX will listen to that time and follow that as well. If you have applications that are more strictly low latency and you don't want to use synchronization, it's not necessary. IPMX supports that as well. So IPMX has the broadest media support. It has the broadest network synchronization spectrum of support. It has so many things that it can do. It's the most elastic one, so it makes sense to be the thing that's in the middle. And you can go from something to IPMX to something else. The reverse is not necessarily true. You would have more difficulty going from IPMX to something else that's the protocol in the middle, and then spitting out to a different format. The thing in the middle, definitely NMOS and IPMX are the most flexible ingredients by far.
Aaron, do you want to add to that?
No, that was perfectly put. Yeah, I think that was good.
IPMX, the Chewy Center. Okay, there you go. Let's talk a little bit about. Let's talk about security. How does IPMX work with HDCP or a high bandwidth digital content protection?
Aaron, why don't you take HDCP and I'll do PEP.
No, yeah, that sounds good. So HDCP, so that is actually already a finalized part of IPMX. So, kind of treating the whole, HDCP like any HDMI switcher or repeater, or just carrying that content protection along. That's all been considered and finalized, and interopt and all of that wonderful stuff. So that was one of the key things that needed to be done in IPMX like right away. Like we knew you needed to carry video and audio and some metadata and things like that, but HDCP in the world of Pro AV with HDMI and things like that, that was one of the core things that was had high priority. Let's just say that, to get that finalized. And so, yeah, even in Plexus's implementations, I know Matrox is in our interops and things like that in our labs. We've got all of that stuff working. So that was, I guess that's done and dusted, if you want to call it that. Well, probably not. It's done and dusted for now until it changes, and then we'll have to amend. But that's okay. That's kind of another one of the points of the future proofness, right? We can amend and keep moving forward with how that stuff changes. So, yeah.
Yeah. So building on the TRs that were specifically to deal with the HDCP key exchange protocol. So the thing that VSF agonized over was there's already definitions in the DCP LLC for how to do HTTP over an IP link. What they did not prescribe, however, was how to exchange the keys. So that's what the VSF worked on, is a standard mechanism for different types of equipment from different vendors to exchange the keys in a common way. And that is called the HDCP key exchange protocol. Using that exact same tool, another exchange protocol was developed called the privacy exchange protocol. And you could use HDCP key exchange protocol and the privacy key exchange protocol in combination. It's not one or the other. You could use one or the other or both. And what privacy exchange protocol does is it allows users or integrators to load privacy keys into their equipment. So if they have equipment from different manufacturers that support the PEP functionality, they could put privacy keys on the equipment so that, on a multicast system, all of the content on the system is encrypted. You can't access the content and use it without the proper privacy keys. So this gives the IT people in organizations a much needed tool to do user authentication so that people can, only pull what they're allowed to pull from a system.
I want to talk a little bit in general about security issues. I mean, what are some of the security issues when dealing with AV over IP in general, and how does IPX address those security concerns?
It's a tug of war between operational effectiveness and security. So, AV is an experiential thing, and a lot of applications are mission critical, and you can't have the audio or video go down. It has to work. So that sometimes fights with security. So sometimes in order to have something be secure, there's authentication, there's steps, there's equipment shaking hands with keys or doing some type of authentication through an authentication server, or there are elements that either affect performance or possibly threaten the actual ability to display content or to play back sound. I'm sure everyone on this call has had the experience where a screen flickers because the HTTP keys between a Blu-ray player and a monitor are, there's a glitch in the key exchange and there's a flicker, and this gives heartburn to people in the AV industry. So there's a fine line, and that's why IPMX is built in, as Aaron described it, a very, very scalable way. So you could bias your IPMX implementation to be operationally very mission critical and very, very dependable in your AV application. There's also plenty of features for the corporate AV that are very security conscious and want to lock things down and make it, much more difficult for the wrong content to end up in the wrong set of ears or the wrong set of eyeballs. So there's tools in IPMX that help people configure the system according to their needs.
Aaron, did you want to add to that?
Yeah, I was just going to say it's not only on the content protection side of it and making sure that no one's stealing your video and audio and things like that, but it's also the control and management layer and handshaking with corporate corporate security systems like LDAP or 802.1x and stuff like that. All of that stuff's been considered from a security and secure communication between devices and the system that actually handles all the centralized control and management of devices and streams and things like that. Whether it's HTTPS or using PEP to encrypt actual content or carrying over HTTP, for HDMI handshakes and things like that. That's all built in and baked into the standards. So yeah, it's kind of overarching the whole. It's been architected, I guess, all of the pieces of the technologies have been architected to be secure. If, to Sam's point, if you're, you have those requirements, you're building a system that would have those requirements, but it doesn't necessarily have to, too. And you could have a total free-for-all system that's super easy to access, which in certain applications, maybe that's exactly what you want. You don't want to be locked down and have to have all these, two-factor authentication things for people to log in and just, watch something or listen to something, right? It scales, and those things can be enabled or disabled. So, yeah.
All right, let's talk a little bit about corporate AV. How does IPMX play in the AV-IT sandbox?
Well, the most important way it restores a flexibility that we've already been enjoying is when you're trying to connect assets of a different type. And I like to consider most things fitting into one of three main buckets in corporate AV. One bucket is media production. So a lot of that equipment is for legacy reasons based on the same kind of equipment that you would find in broadcast. There's a lot of SDI signals. There's vision mixers and production switches and things like that that use elements from the broadcast world. There's AV signal routing and signal management. So this is where you have your touch panels, and you could direct audio to certain speakers. You could direct video to certain screens through very site adapted or room adapted interfaces. There's a whole economy of services provided by AV integrators that's what they do for a living, is they personalize the AV routing experience for businesses. And the third, and by far the biggest bucket, is the PCIT asset bucket. And this is where a lot of your corporate communications live, your Microsoft Teams, your Zoom applications. And the IT department is often involved in that type of, Windows machine or whatever. Now, historically, it's been possible to connect these three asset classes together fairly easily. AV equipment has an HDMI connector. IT PC equipment has an HDMI connector. Maybe some of that broadcast or production equipment was SDI, but there was a huge economy of little mini converters that were cheap, very, very high performance, super reliable, and required no skills to use. So it was really a problem solved. So you could connect all of these three asset buckets to each other, no problem. The problem today is that they're all moving towards IP. They're gradually migrating towards getting rid of those baseband connections. They're still going to be around for a long time, but they're phasing them out gradually and going more towards IP input and output, because you could have better channel density, you could have better distances, you could have better switching. There's a lot of reasons to do so. So remaining in IP between these asset classes is now a brand new problem, because the production equipment is going primarily towards things like 2110 and NDI. The AV routing stuff, well, there's a whole slew of those things. There's individual brands that have their own implementation. There's some chip solutions like A-Speed and Semtech. Semtech is the chip provider for SDVOE. There's some proprietary protocols like Dante, and so many solutions. And then on the PCIT side, that's never going to change. The blocks that accelerate your media on your phone, on your tablet, on your laptop, the reason you could watch a Netflix movie on your phone is because there's hardware blocks that specifically accelerate certain codecs and give a very, very good performance with a very minimal usage of power. So it keeps the networking bandwidth very manageable. It means that the chips that you could use for networking on your compute equipment can be manageable. The use of processing cycles on your equipment is hardware accelerated so that, again, battery life is maximized. And so in the PCIT world, there's going to be some form of reuse of those accelerated codecs. And that's a lot of H.264 and HEVC and things like that. And sure, there's going to be some other mezzanine codecs that also get used, but by and large, you need ways to talk to the mass of equipment. So IPMX is the only thing in the market that actually has the breadth of media and network condition support to keep all of these things in IP. Sometimes there's a direct link where the media is already compatible, And in the worst case, you need some type of IP to IP gateway, which could be implemented in hardware, or it could be implemented in software that converts something from something to something else. And you can stay on IP without going back to an HDMI connection or an SDI connection. And why remaining on IP is so useful and helpful is, those help desks, those famous help desks where people are, being called up and, hey, the monitor in conference room 300 is not working. They don't know if that HDMI cable is connected, or if the cable is connected but it's defective or whatever. People are dying to have diagnostic information on their system, and there are some amazing network monitoring tools and media monitoring tools that are already in the market, and they're already adding support for NMOS and 2110 and IPMX, and these are hugely valuable things to have that awareness of what's working, what microphones are hot, what displays are available on a system. So that ability to get past the limitations of baseband cables is a very, very big deal.
Well, now we're running a little short on time. I have a lot more questions for you guys, but for the sake of making sure I get to ask a couple of questions from the audience, let me end mine with this. For integrators who want to incorporate IPMX into a project, are there any special considerations for its use?
Outside of really just going with we're working on the best practices document and even how to select network gear and stuff like that. I wouldn't say there's anything necessarily like completely outstanding with IPMX because of its ability to scale from 1 gig to 10 gig networks. So you're not going to sit there and get pigeonholed into, say, a gigabit network, or now I got to consider uncompressed, and now I got to do a 10 gig network. It'll scale depending on what you're trying to accomplish from just like a system architecture thing. Really what it's going to come down to is just then, the basic things you need to configure in your network, like multicast if you want it, or, any of those kinds of just like, actual network infrastructure type settings. Outside of that, it's just your normal IP infrastructure stuff. And just making sure that you understand the best practices and get your routers and switches configured. And I really think that's the biggest piece of it. Past that, it's kind of built to be as plug and play as possible, and having management and the network control and stream control is a part of the technology. So not only can you route the things around, but you control them and monitor them and have what Sam was even talking about from the people at the call desk. They have the visuals to actually go look and go like, oh yeah, I see that device is turned on. Oh, I see that this video just happens to not be routed on it. Here, let me fix that for you. And they, go into some kind of control systems web interface and click it, and then the people in the conference room are happy after that, right? That's kind of the whole idea of it. So, yeah.
And I should point out that when it comes to selecting a switch and configuring a network, all of the protocols have trainings on how to assure quality of service and best practices and things like that. So that's a staple of any AV over IP system, regardless of whether it's IPMX or some other protocol. IPMX is no easier or more difficult when it comes to understanding the basics of networking for media. The thing that IPMX does is it strives to handle a lot of the things that people face from a device point of view on a system that is AV over IP. And we expect that building a competent AV over IP system with IPMX devices is going to be an easier experience from a ease of configuration and ease of maintenance point of view versus the other protocols over the long term.
Excellent. All right, let's get over to some Q&As from our viewers. This one's from Adam. He asks, is an IPMX network a standalone network, or can this technology run on traditional existing IT corporate networks? Or what would need to happen in order for it to run on corporate networks?
Yeah, so I don't know if the basis of that question is the reputation that 2110 has is that it requires special switches. This is sometimes true because a lot of 2110 devices happen to implement the most extreme level of synchronization. So you need those boundary clock switches. They're a bit more involved to configure, and they're a bit pricier. So IPMX devices can work on a network of that type, no problem. But of course, you could use standard IT corporate equipment with IPMX devices as well. So IPMX devices will work on a corporate IT network. The question of whether you should or shouldn't, that's a different question. So, considering when it's appropriate to put media on your corporate network, when it's appropriate to have at least a VLAN, and when it's appropriate to have a dedicated network, that's a discussion for the AV team and IT team to agree on. But is it possible? Absolutely.
So you're saying the IT and AV people have to agree? Oh, God.
Everyone has to play nice, people. Okay, I think we got time for
It's a community. It's a community.
It's a community. Keep the community thinking going. All right, David's got a question. Is there a common metadata for IPMX 2110 and AES 67?
Yes, so the ancillary information in 2110 is based on SDI, and the ancillary support in IPMX builds off of that same 2110 slash SDI philosophy. So all of the ancillary support that you have in SDI, that was ported to 2110, and that was in turn ported to IPMX. Now, at a vendor level, some of them also further enhance their products to support the metadata types of other things as well. But the minimum provision of IPMX is that it has to support the same type of ancillary as SDI and 2110.
All right, fair enough. I don't know if we got time for this one. We're going to try. Ryan asks, doesn't adding another layer of IPMX into the flow create more latency and more points of failure? Can you answer that in a minute for me?
Yeah, I think I can. So with the whole islands and connecting islands, this is usually just a gateway type function. And this could either be hardware or software. Could it be a point of failure? I can't really contest you there because yes, you're at least introducing probably one more physical thing, whether it's a PC running software or like a hardware device that has, just IO and does the conversion. But is it more complicated? I would say no, just because of the way the IPMX standard's been written from a management and control perspective. Like, yes, you have that box, but now that box is now very interconnected with the rest of the IPMX system. So routing said streams to and from those islands, I think, is just as easy if it was just a native IPMX system. So I feel like it's got that covered. Yes, you'll have something that needs a power supply or maybe be PoE plus or something like that. But past that, I don't really think you're adding a terrible much complication there, or cost for that matter, depending on what you're converting. So.
All right, that's
you
great,
have a lot
guys.
of choice. Oh, sorry. Okay.
All right, yeah, we're out of time. So we're out of time, and we want to thank everybody for being with us. There is an Amazon gift card winner that we do need to announce before we leave. Congratulations to Steve Scorzetti from Pennsylvania. You won the Amazon gift card for this webinar, so congratulations. Sam, Aaron, thank you so much for today's discussion. Clearly, there's lots more to talk about this, but at least we did get a nice overview of what IPMX is and how it can help. If you've got more questions about IPMX, you can find answers at aimsalliance.org. That's AIMSalliance.org, or at IPMX.io. That's IPMX.io. Thanks again, everybody.